Hello, I'm Mr. Manley, and today I'm going to talk about rational functions. A function, of course, is an equation, and I would expect that up to this point you have seen some different functions. For instance, if we look here on the right side, you should recognize that as a type of function, a quadratic, simply by looking at it and considering that it looks like a specific type of quadratic that you've seen before, or possibly that it, if you were to expand it, you see that you would end up with x squared, and that makes it a quadratic. And we know some things about quadratics. What we want to do today is develop knowledge, understanding for another type of function, this function on the left here, which is a rational function. Now, the first thing, something to consider about a rational function, like a quadratic, is what's its basic shape. So for the quadratic, if we look up here to the right, of course, the basic shape is a parabola. For the rational function, the basic shape is, and we'll look down here to the right, in the bottom right-hand corner, this is the basic shape. Now you may want to consider, how do we get to this basic shape? And look, whenever we have an equation, a function, any sort of relation, if we want to get to the graph of it, we can just find some points, right? So a typical way to begin might be to look at a negative point, to look at 0, and to look at 1 and see what happens. So if I plugged in a -1 for x, I'd get -1. If I plugged in a 0, okay, that's interesting. 1 over 0. Hopefully you know that's undefined. So there's no value, no output for 0. And then if I plug in a 1, I get 1. So at this point, I would just have these points here, say, like 1, 1, and -1, -1. Now, if I wanted to explore this further, and I went out and said, well, how about 2? And then I'd get 1/2. And that might be this point down here, if I look to the right on that rational function. And then if I put in -2, I would get -1/2. And as a matter of fact, as I keep putting in larger and larger values, this 1 over x here, if you think about, well, what if I put in 100? So what if I put in 100 for x? That's going to be 1 over 100. And what if I put in 1,000? That's going to be 1 over 1,000. So what's happening? It's getting closer and closer to 0. And that's what you can see in the picture. That if we look down here to the right, that as this function down here, as I increase the value of x, it's getting closer and closer to 0. That's happening on the right, or on the left, I should say. Here, as I use larger and larger negative values, so let's look at this function again, the basic rational function, as I use like -100 and -1,000, it's getting closer and closer to 0. 1 over -1,000 is really close to 0, but it's occurring from the negative side, and hence we get this graph. And this is what we would say is the parent function down here on the right. That's the parent function for a rational function. So notice that this function has asymptotes here, and I'm going to highlight those in red if you're looking down at the right still, and you see there are these asymptotes, and these are values that are approached, lines that are approached. So this is what we want to do with this function here up on the left. We want to find the asymptotes and then approach the asymptotes. And I'll just say, generally speaking, that look, these are the types of graphs that we're going to see. We're going to see like we did on the right there, and then another thing that we could see are graphs that look like this. That's a rational function. And another one that we could see is going to be kind of similar. It's going to look like this. All right, so there's kind of a lot going on there, I'm sure, but you're getting the basic idea. We have these asymptotes, and then we have these basic shapes that are going to approach those asymptotes. So let's go ahead and look at one. The first one that I'm going to look at is here. Now, first of all, notice that independent of studying rational functions, if I had this function, I could ask about the domain. We have done that, right? Or I'm sure that you must have done that. If you're looking at a video on rational functions, that you've been asked about the domain of a function. And what's the domain of this one? I don't want the denominator to be 0, right? So I say x does not equal plus or minus 2. Well, guess what that does? That tells us that if we look to the right here, again, look over at the function on the right, what's the domain here? X cannot equal 0. Well, how does that manifest in the graph of the function? It manifests here. There's nothing happening at x equals 0. There's an asymptote. So this domain note here is really telling me about the asymptote, and specifically it's telling me about the vertical asymptote. So the domain is giving me the vertical asymptote at x equals plus or minus 2. Okay, from here, we need to find the vertical asymptote, and you'll notice in the function on the right that we had a vertical asymptote. If you look back down to the right-hand corner, we had a vertical asymptote, and we had a horizontal asymptote. All right, so the horizontal asymptote, I'm going to give you some rules for that. Here are the rules for horizontal asymptotes. So why don't you take a moment and read through those. If the degree of the numerator is less than the degree of the denominator, as is the case in our function, let's look at it. See, the degree of the numerator is less than the degree of the denominator. Then there is a horizontal asymptote at y equals 0. If the degree of the numerator is equal to the degree of the denominator, then there is a horizontal asymptote at y equals a over b. And I've got an example of that. So here, degree 2, degree 2. So the degrees are equal. Therefore, I'm going to have a horizontal asymptote at y equals 2 over 3. So that's going to be a horizontal line at 2/3. Okay, and then finally, if the degree of the numerator is greater than the degree of the denominator, like if I just quite simply had f of x equals 3x squared over x plus 1. All right, that is degree of the numerator is 2, degree of the denominator is 1, so there is no horizontal asymptote, but there is a slant asymptote at q of x. And I will examine this possibly. You might be able to find that I have another video that specifies that. So we're not going to deal with slant asymptotes in this video. What we are going to do is go back here and do our horizontal asymptote. Again, the degree of the numerator is 1. The degree of the denominator is 2. So following the rule, there is a horizontal asymptote here. If you look down at the bottom, horizontal asymptote at y equals 0. Now let's look at what we do with this information as far as graphing it. Graphing it, I'm going to graph the vertical asymptote at positive 2, if you look at the graph on the right, and negative 2. And I'm going to graph a horizontal asymptote at y equals 0. I just put that in red. Now from here, all I need to do is figure out what is going on. Is the function above or below the x-axis? Is it above or below the x-axis, above or below in each region? And the way I'm going to do that is by substituting a value. So if you look down at the table of values here, I'm going to substitute a value of x from each of those, I would say, regions. Now in the table, I have a value of x from each region, and I'm going to plot that point. So this first one here, -3, -1, is going to be here. And then that is all I'm going to say I need to know. Once I've got it that it's down there, I'm just going to approach the asymptote from there. Now the middle region is going to be a little bit more difficult. So let's go to the right region first. And that's this point here, the bottom point, 3/7/5. So that's 3/7/5, and it's something up here, actually. What is it? Yeah, 1 2/5. So something up there, and then I'm just going to approach the asymptotes from there. So I'd approach that asymptote, and then I'm running out of room on the right, but it's going to approach the asymptote from above on the right. So hopefully you followed that. I'll highlight those parts that I've done. Lower left-hand corner, I have this, and upper right-hand corner, I've got this. Now in the middle, if I plot this point that I've got, look down on the left, 0, -1/4, so that's here, 0, -1/4. Now I do have to figure out what's going on to the right and left of that point. So looking at the table, down at the bottom of my table of values, I've got 1, -1, which is, I'm going to plot that point on the graph. If you look at 1, -1, I've got -1, 1/3. I'm going to plot that point on the graph. So you see these 3 points. I need to get through these 3 points in the middle, and I need to approach the axis, or I should say the asymptotes. And with that, the graph is complete. So that's your intro to rational functions. There's a couple of nuances. We got to deal with the slant asymptote, which will require another video, and there's one other issue that I would need to deal with as well. So you should either get that in class through instruction or look out for another video. Thanks.